4 people there. I'm gonna just let them in. And then because I didn't get a recording first period, it stopped recording. I forgot to restart it. All right, here we go. These people are all welcome to math class. Tristan, Jenna, and Olivia's coming in here too. We'll get started in just a moment. If you could all turn to lesson number 8 in your note packet, it looks like this. It's the last lesson we'll do, and we'll do a quiz tomorrow. Knowing that this is a long day of notes, a normal day of notes, it's going to be 30 minutes. You're going to have a quiz later this week. My guess is tomorrow. So you want to prepare for that. You'll probably have an opportunity to do another makeup quiz. If you don't do well on the one tomorrow, like do it on Friday. That's up to you. I believe that's all I have for announcements. This is our last day of notes in lesson unit 8. So I think we should begin. If you're all there in lesson 8, if you can't find it, let me know. All right. We're going to consider a rectangle whose area is 45 square feet. Now, because these are word problems, I'm going to have my tools ready. These are my tools. I have, believe it or not, this is a green pen, a pink pen, and a yellow highlighter. I like all my highlighters because that will help you learn, hopefully, obviously, but it also will help you when you're in the Regents to sort out these word problems by the parts that make up. So let's read this first problem, and I'm going to highlight some different areas. Consider a rectangle, so I'm going to draw a rectangle whose area is 45 square units, in this case, square feet. So I'm just going to write 45 in the area part of the rectangle. If we know the length, and now this is important, I'm going to highlight it, and not everything, just this part. The length is 1 less than twice the width. 1 less than twice the width can be summarized using a math expression. If something is 1 less, I'm going to subtract 1 from something. That something is twice the width. So I'm going to say 2w minus 1. Then we would like to find the dimensions of the rectangle. So if we know the length is 1 less than twice the width, we'd like the new dimensions. All right. If we represent the width of the rectangle using the variable w, which I already did up here, then write the expression for the length of the rectangle L in terms of w. All right, so I think you know what we're trying to do. We're trying to say, what is L in terms of w? So we need to say, well, take this expression and rewrite it. Just make it equivalent to the length. So L equals 2w minus 1. That's it. That's the first step of understanding how to do these word problems, is knowing how to break word sentences into math sentences, or in this case, expressions, and then finally equations. Set up an equation so it has an equal sign that could be used to solve for the width. All right, so we need to think about how all of this relates to our width. Based on the area. So do we know any formula that has area in it, length, and width? Of course, yeah. Area equals length times width. Knowing that, we can substitute what we know from up here. We know that area is equal to 45 square units, in this case feet. Length is equal to 2w minus 1. And width is equal to width, w. All right, I could say I'm done here, and I'm mostly done here. What I've done is set up an equation, and I didn't solve it though. And that's probably, you can guess what we're going to do next. So let's go ahead and do that. Solve the equation and find both dimensions. So we rewrite the equation, 45 equals, and I'm going to write the w first. Usually we write the single variable in front, 2w minus 1. Now in this case, I'm going to distribute the w into both terms. I can zoom in here if that helps. And I get 45 is equal to 2w squared minus w. Now, at this point, you want to decide what to do next. Do you see how there's two variables terms with variables and a single number. We're going to make this, set this equal to 0. Sometimes we set, if it was just 1w, I would just set it equal to a number and then solve for that number. But there's 2 terms with w, and so we're going to have to treat this as a quadratic, not just because it's squared, but because there's 2 terms that we can't combine. So I'm going to minus 45 from both sides. So the left side gets to be 45, and the right side is 2w squared minus w minus 45, because notice I have minus 45 from both sides. At that point, I'm going to factor this. And this one is a hard one. I'm not going to lie to you. This one is a hard one. I'm going to put 2 parentheses. I'm going to ask you stuff by thinking, and hopefully you have some practice with this, by doing reverse FOIL or factoring. I need to somehow find 2 numbers that multiply to be 2w squared. Do you agree they both have to have w in there? That's the w squared part. I'm going to throw a 2 in there because I know 2w times w does equal w squared. That's the only way. Yeah, question?
Cassie just wanted me to tell you that she has an eye appointment, so she's not going to be here today.
All right, Jenna, thanks for letting me know. Anyone else have anything? If you have friends who are trying to get in, let me know if I forget, you know what I mean? Because sometimes if they pop in now, I'm going to be so focused on explaining it, I might forget. So we were at the first step of factoring. If we did FOIL on this, we'd get our first step to be 2w squared. I was just trying to prove to you that that is the 2w. Now I need to somehow figure out what will go in these spots. Well, we know they have to multiply to be 45. So let me just write down the factors of 45. And I believe 9 times 5 may play a role here. But do you see how I found some factors of 45, and that's one of them. Now I could have done 3 times 15 if I wanted to as well. But I'm going to look at this problem and ask myself, I know these 2 numbers will have to be 5 and 9, or 3 and 15, or 1 and 45. I have a feeling that's not 1 and 45, because when I add them up, even after I double one of them, they have to be a difference of 1, because that's a negative 1. So what group of numbers, 5 and 9, or 3 and 15, could be combined to be negative w? So let's try out some, and I'm just going to try one. Let's try plus, and this is a trial. This is like, I'm not sure this will work, so I'm going to put a little question mark over there, and I'll show you how to work your way through it, because this one you just have to guess and check. Oh, good, why it's there. All right, so I'm going to try 9 and 5, and I need to know what sign to use. Do you agree? Because this last number is negative 45. I'm going to have to make the signs different. Okay, to check this, I'm going to teach you something today. It's called the OI check. Outside, inside. The in-out check, or the OI check. What I mean to do with this is I'm going to see if they add up to the middle term when they're complicated, because this 2 is complicated things. 2w times negative 5 is negative 10w. 9 times w is 9w. And if you add these 2, you'll get negative w. And do you see how that is our middle term? Check. So these are the 2 answers. We have 2w plus 9, and we have w minus 5. And we're going to set each of those equal to 0. Now that's very important, because we set this equal to 0 for that very reason, to use what we called the 0 product rule we learned yesterday. So we set them equal to 0. I'm going to move this over. And then we need to solve for it. So I'm going to minus 9 from both sides. Then divide by 2. And on one I get negative 4.5. On the other one I get, adding 5 to both sides, 5. So one of these is the right answer. Both of these are the right answer. Or what do we do? Or neither one? Well, because we solved for it algebraically, if our math is right, one of these are the right answers. I'm going to say not the other one. Why is one of the solutions not viable. Viable means alive, but in this case is a good answer. So which one isn't a good answer to have to the question, what are the dimensions of this rectangle? I'm going to put a red X through the one that's incorrect. And I wonder if you can guess why. Does anybody want to guess why that one is incorrect? I got a chat here. Let me check it out. That's correct, Jenna. And could anyone guess why? I'll put you on the spot a little, everybody, but everybody's in the same boat. So here's the explanation. I'm hoping maybe some of you were thinking, but either way, I'll lead you to it in this case. You can't have negative distances, guys. So what we know about the world, when we talk about a distance, it's always a positive distance. Even if you're going backwards, it's a positive. And the vector is a different thing, but a distance is always positive. So we can't have a negative. And so do you see why I dismissed it? So if I know W, one of the width equals 5. But what is the length? Because they ask, excuse me, they ask for the dimensions. So if I know the width is equal to 5 feet, is there any way I can find the length? Because they want to know the dimensions. Both dimensions, that means the length and the width. Well, we happen to have this equation up here. We have length is 2 times W minus 1. So the length is 2 times 5 minus 1, which is equal to 9 feet. So we have both dimensions. It's a 5 by 9 foot, we say in construction. All right. And we often say square feet if we write it like that. But we can say 5 by 9 foot, it's fine. Okay, any questions on the first one? Now let's move on to the next one. This one is a little more complicated. Could you underline words with me as I read it? And again, it's awesome if you have a highlighter to use, but not everyone does, so I'll just leave it as that. Square has one side increased in length by 2 inches, and its adjacent side is decreased in length by 2 inches. If the resulting rectangle has an area of 60 square inches, what was the area of the original square? First, draw some possible squares and rectangles to see if you can solve by guess and check, and then solve it algebraically. Can someone throw in a guess, I don't know, 1 through 20, what they think the length of one of the sides of the square could possibly be? That if you add 1 and subtract 1, it will have an area of 60. What would the original square be? Any guesses? Here, I'll throw in a guess. Let's say we just guessed it was, this will be our guesses, okay? We're not going to, I'm going to solve for it, but first I'm going to guess, let's say it's 5. Is it 5? Well, if the original square has lengths of 5, do you agree its area is 25? And if we went through this process, it says of saying that the one side increased by 2 inches. So W plus 2. And then the adjacent side decreased in length. You know, I don't even need to write W, I can just write X because all the sides are equal. The length increased by 2, and this says the adjacent side decreased by 2, so the adjacent side is X minus 2. So what we're saying here is if this was originally 5 by 5, it would transform to a 7 by 3, and its new area would be 21 inches squared. And that is not true because it says its new resulting rectangle is 60 square inches. So here's some important piece of information we're translating. We have to understand the new square is 60 square inches. The length was increased by 2 inches. And its width was decreased by the same amount. Those are really the most vital pieces of information in the problem. Let's do this algebra. Our first guess didn't work. You noticed we wanted it to be 60. We guessed 5 and 5. I could keep trying like 7 and 7, 8 and 8, and maybe I'd find it. Let's just do it algebraically, see how hard it is. we got x and x, and then we're going to increase the length by 2, right? And decrease the width by 2. So this is going to be x plus 2, and this will be x minus 2. Same way I found that 7 by 3. And we know the product of this, length times width. So the area is supposed to be 60 square inches. So it's x plus 2 times x minus 2. Now I'll show you with this problem, it's going to be a little different than the last one because factoring and setting equal to 0 may not be needed. Let's just see. We're going to do FOIL on this, and we'll get x times x is x squared. X times negative 2 is negative 2x. 2 times x is positive 2x. And 2 times negative 2 is negative 4. The middle terms cancel, and we have 60 equals x squared minus 4. Now you notice in this one, there's only one x term. So we can actually get it to be x squared equals a number. Let's do that. Whenever we can do that, we want to do that. So I'm going to add 4 to both sides. And that's sort of nice. We have 64 is equal to x squared. Now, understand what this question means. It's asking me very specifically that if you square a number, you equal 64. But let's say you don't know what x is and you want to know the answer. Well, the answer to this question starts with solving it, which means you have to undo a square. You may or may not remember, but the undoing a square is just square root function. I'm going to pull out the calculator and just remind you how to do that, okay? So we want to write square root of 64, and we can then solve for the answer. So the first step I'm going to do is undo the square by square rooting. So I end up with x equals the square root of 64. And now I'm going to try to do that in my calculator because it won't always be this easy. Some of you already know, I know. Here's how you do it. You look for the square root function, and you'll find it here, just a diagonal of 7. So you see there's 7. It's adjacent to the comma and the log button. Now that blue function is the part we want, so we have to press the blue button to activate the square root function. So I'm going to press blue square root, and I have the square root there. Now I'm going to type in 64, and that's all there is to it. We just press enter, and the calculator will tell us an answer. Now that answer is partially right. It is 8, but I said partially because of this. There's actually 2 different numbers you could square and equal 64. One of those is 8. 8 squared is 64. But there is another one, and I need you to remember this. The square of a negative number is also positive. So if you know you square a number and get another number, that means there's 2 distinct numbers that can always be squared to get that same number. The negative version of it and the positive version of it. So the square root of 64 is actually plus or minus 8. It's weird but there's those 2 answers. But we can get rid of one of those, right? We know it has to be 8 inches because that minus sign doesn't make sense for distances. So we know the original square was an 8 by 8 square. And it wants to know, first draw some square. If the resulting rectangle, what was the area of the original square? 64 inches squared. So this is my answer statement right here. I drew it and I listed the answer, 64 inches squared, and that's how I found it. Anyone have questions? Okay, we have 2 more. Now, this one gets a little dense, so a highlighter or underlining is super important. There are 2 rational numbers. Well, what's a rational number? It's any number of A over B. I'll get more into it in a second. I'll read it first. That have the following property. When the product of 7 less than 3 times the number is 1 more than the number is found, it is equal to 2 less than 10 times the number. So when I read that, I'm like, whoa, dude, just speak English. Now, I'm the one reading it, so let's figure out what they're trying to communicate. Well, they're communicating way too much for such text. Math is the language they should have used, but they're trying to use English. And this is why we use mathematics, because it makes things a lot simpler. It says when the product. Well, what does product mean? We learned that rational numbers mean something, and I'll tell you what that means. It means it could be a fraction like 2/3. It could be a fraction like 7 halves. Rational number could be just the number 2 or 12. All right. A rational number, these are all rational numbers. Okay. Irrational numbers are like pi and radical 2, because they go on forever and never repeat. All of these can be written as a fraction. These two cannot. So these are called irrational numbers. And that's usually a good way to remember rational numbers. It's everything else. So every number we've ever worked with has always been rational so far, other than occasionally we use pi in school so far. So there's two rational numbers. They have the following property. The product. So first of all, we have a product of two numbers. All right, I'm just going to put that. The product of, and I need to figure out what this stuff in pink means. 7 less than 3 times the number. And I need to know what this yellow part means, because it's a product of the pink stuff with this, 1 more than the number. And then if you're super big brain, we need to figure out it is equal to 2, and this is the second part. Go back to my, it's equal to 2 less than 10 times the number. All right, so we have a little bit of work to do, and it's just unpacking it mentally. I'm going to say let x, but I could have used n. I'm just saying let x equal a number. That's all they said it was, a rational number. All right, in the first sentence in the pink part, 7 less than 3 times the number. If something's 7 less than something, I'm going to put -7. And it says 7 less than 3 times the number. So 3 times x, because it's a number is x, so it's 7 less than 3 times the number. So this is the product of 1 more than the number. How would we write 1 more than the number? Just x plus 1. Is that good? All right. The next step is it is equal to, so that means equals 2 less, so -2, 10 times the number. Now, that might be complicated, but it is not complicated to write. This is the kind of equation people like to solve because it's now abstracted in a way we can deal with it. When it was all in context of literacy, it was hard to understand, but now it's in the context of numbers, it should be easier. I'm going to do FOIL on this because I have been doing FOIL, but I could have done double distributive. 3x times x is 3x squared. 3x times 1 is 3x. -1 times 7 is -7x. -7 times +1 is -7. All right, I'm going to combine like terms. And then I'm going to set it equal to 0. There's 2x terms, so I can't just solve for it. So I'm going to -10x from both sides and add 2 to both sides, all in one step. Oh, and that's a -14x. It's sort of overlapped there. And this is a -5, and that equals 0. Now we have the same dilemma as before. We have to factor this and keep it equal in 0. Is there any GCF, any common factors? There isn't. So I'm just going to have to factor it knowing that 3x times x does equal x squared. And 1 and 5 are the only things to multiply to be 5. All right, so keep that in mind. It could be 5 and 1, I guess, but I know this is right. I'm going to walk you through how I know the signs of each of these now. Everybody see where I got 1 and 5? They multiply to be 5. I know one of them has to be negative and one of them has to be positive. So I also know that I'm going to do an OI check here and see if I can figure it out. The outside and the inside. The outside is 3x times 5. So let's say that, let's say I make this plus. And this one minus. I'm going to do the outside term, which is 3x times -5, which is -15x. Then I'm going to do the inside, which is 1x. And if I combine these, I get -14x. And that does match my middle term. I believe the middle term is -14x. Yep. So this is my factor. So I set each of these equal to 0. 3x plus 1 is equal to 0. And x minus 5 is equal to 0. Then I'm going to add -1 from both sides. And then divide by 3. Over here, I can just solve for it in one step by adding 5 to both sides. Oh, you know, I have an eraser for a pen. It's actually sort of cool. It's just a tape that you put over your paper. And then it sort of like, look, I'm running out. Anyway, makes it easy to write a correction. I was just going to solve for this. It's going to be x equals 5. You all see that? And that's the only number -5. All right, so we have our answers. And we look back at the problem. This is rational numbers. These are both rational numbers. Oh, they could have been like -11. Don't forget that the rational numbers can be negative or positive. Find the two rational numbers that fit this description. These are the answers to the question. All right, last one, guys. Last one. These are not an easy day. In fact, this is the hardest lecture of Algebra 1. These are the hardest notes and homeworks for Algebra 1. So I've told you many times, this is the third hardest topic. This is the second hardest topic. This is the fifth hardest topic. Now we're at what I believe is one of the hardest topics to understand. Because you're taking quadratics, making them into formulas and equations, and solving them with purpose, knowing that you have to set them equal to 0, knowing you're going to have to know how to factor. Now, one thing, factoring this is harder than you have to do on the regions. The regions won't include numbers up here unless it's a common factor. So actually, we're doing things harder than the regions, but if I teach you things that are harder, hopefully when you do them on the test and quiz that are easier, you'll do even better. But I just need to teach you at the highest level. Algebra 2 is not an easy course. You'll need to know how to do it for there as well. Find all the consecutive integers such that the product is 8 less than 10 times the smaller unit. Okay, now you might remember doing consecutive integers. All right, those were pretty fun. They were like x and then x plus 1. You remember that? And then x plus 2. Those are all consecutive integers. Examples of consecutive integers are like this: -5, -4, and -3. They're consecutive because they follow each other on the number line. They're adjacent because they bump into each other. Consecutive is the same idea. They follow each other. Find all sets of 2 consecutive integers such that their product is 8 less than 10 times the smaller integer. So I'm going to first let some numbers and variables equal to each other. So I'm going to let x equal the first consecutive integer, which is also the smaller one in all cases. Consecutive integer. And you probably can guess the next consecutive integers, no matter what x is. The next one is x plus 1. And this might be the first time you write the word consecutive, so take your time. And it might be your first time writing integer. Who knows? Okay, we found that. Now we're going to have to make an equation after what was given to us. Here's what was given to us. Such that their product, 2 consecutive integers product. So we're going to multiply x and x plus 1. X times x plus 1. Their product is 8 less. That means something minus 8, 10 times. So that's 10x minus 8. That's weird because that's similar to the last problem. Okay. Is 8 less than 10 times the smaller number? Okay. And you see how smaller number is x. So if we're good with this, we can get to solving it. All right, first thing I'm going to do is distribute the x. I get x squared plus x equals 10x minus 8. Now I'd love to just solve for it in one fell swoop, but I have to get set it equal to 0. So I'm going to minus 10x from both sides and add 8 to both sides. So this is x squared. This is minus 10x plus 8. So this is negative 9x plus 8. All right. Now we're going to set this equal to 0 and solve for it. All right, let's do that over here. So we have x squared minus 9x plus 8, set it equal to 0. It means I'm going to drop the parentheses. And this one is relatively simple, so we could play the x game if you'd like. What two numbers multiply to be 8 that add to negative 9? And because it's a positive number, we're going to multiply two numbers, and there's only two numbers that add to 8 and sum to negative 9. Well, it's negative 8 and negative 1. So I'm going to write x minus 8, x minus 1, and I bet you can guess what's going to come next. I'm going to set each of these equal to 0 separately and then solve for them. And it will find me my two x's. X minus 8 is equal to 0, so x must equal positive 8. X must equal positive 1. So those are my two answers. How do I write my set of answers? Well, 8 is alone, y is alone. Remember, this x represents the smaller of the two integers. So the answer is this could be 1, right? Or it could be 8. And this, the second consecutive integer, well, adjacent to 1 or consecutive to 1 is 2. Consecutive to 8 is 9. So all of these four are our answer, and the way we list them is like this: 1 and 8, 2 and 9. That's one way to list them. All right, that concludes our notes. Let me just go over what your homework is tonight. It's only the first page. Okay, 1, 2, and 3 are the homework tonight. That concludes our lesson. I know it's a long lesson and it's a hard lesson, and I try to mention that. So do your best. Try the homework, but don't spend more than 20 minutes on it, okay? Does anyone have any questions? All right. Hey, White, good job with the game yesterday. All right, I think I'll stop the recording. And then when you guys head out, I'll stop the recording and post it.